Hey guys, welcome to our channel Coders Arcade. This is Ashang David, and in today's video, we are gonna talk about a important interview question which is generally asked in interviews, and this question is related to linked list concept that we have already done. We have a lot of videos created on linked list concept where I have explained you about how to create the linked list, what exactly is a linked list, and how you do all the operations on the linked list and data structures in C++. So if you haven't watched those videos yet, I will give the link in the description below for those videos as well. And you can go ahead and watch those videos as well. So you will understand this question very well. And let's get right into the topic. So this is the question here. The question says that we have to find the intersection point of two singly linked lists with a twist. Okay, so let's see what exactly it is. The problem statement says that you have encountered an interesting linked list challenge that involves finding the intersection point of two singly linked lists. However, there's a twist. You are not allowed to modify the original linked list by adding any extra data, pointers, or attributes. Your task is to implement a function, node, find intersection, where we are giving two lists, the list 1 and list 2 in C++ that returns the intersection node. So basically, this function we need to create, and this function is going to tell us what is the intersection point. And if it exists, or null pointer if there is no intersection. That means we have to return null pointer when there is no intersection, and if there is any intersection we have to return that particular node itself. The catch is that you are allowed to use constant extra memory, that is O of 1. That means our space complexity is going to be O of 1 for this question. Now what they are saying next is the node class is provided for you and has the following structure. Okay, so code is already given to us. Half of the code is already given to us. Most of the code is already given to us actually. We have to just write this code. So we will see what exactly it is. So it says that class node, and this is the class that they have created for us, and the two input linked lists, linked list 1 and linked list 2, are given as the respective head nodes. It's guaranteed that the lists have a non-negative length and then the intersection point is valid. What are the constraints? You must not modify the original linked list or introduce any additional data structures. Your solution should have a time complexity of O of n and the space complexity of O of 1. So O of n is going to be our time complexity. So we have to make sure we don't use any more for loops into this particular challenge, and we have to do it in as less as time as possible. Space complexity is O of 1, so we can use one extra constant space that is allowed to use. So as an example, you can see I'll zoom it in here and you will see that in a much better way. I'm going to show you that you see here, this is the linked list. We have list 1, which is 1, 3, 5, 6, 7, and the list 2 is 2, 4, 6, 7. So both of these list 1 and list 2 are intersecting at this point at 6. So basically, the input will be given as two linked lists and it will return the node where the intersection is 6. In this example, two linked lists intersect at node value 6. Your function should return the pointer to this node. So this is how it has to be done. Note, this challenge is designed to test your ability to work with pointers and linked list traversal efficiently, even under constraints that limits memory usage. All right. So we are ready to do this, and let's read our code first and understand what exactly the code says. Let's go ahead into the code. Right, so this is our code, and here, as you can see, I'll just zoom it in here a little bit. You can see the code is already given to us. Most of the code is in fact given to us, but we have to write only one function that I'll come across very soon. So here, what they have done is here they have created the class node, and they have data next and the node. Okay, so this is the constructor. So for those people who don't know, this is one of the shortcut methods of writing the constructors. So in this case, they have given val as the parameter here, and the data and the next are the attributes or the members of this constructor. Now coming to the linked list class, they have created another linked list class. They don't have to, but they have created it. So now if I want to call this, here I need to create the object of that linked list class first and then work with it. Anyways, let's go here and see what's there. So first they have created the head and they have initialized the head to the null pointers using the constructor of the class linked list. That is fine. Now what they have done is they have created void append function. So they will be doing append using this append function, and they will be creating two lists, list 1 and list 2. They will append and create the list 1. What they have done is that they have created another function here called getTail, and which is going to get the tail of the linked lists whichever they are saying. Then they have created another intersect function. Now this is not the function that we have to write. This is the function that they have already written, and they have called this function there, down there, and they have already intersected. What we have to write is this function, find intersection function. Now in this function we need to understand how we need to intersect how the linked list is going to get intersected and from where. I will do that. So first read the main function first. Here we have list 1, and using the append function they have created list 1, 1, 3 and 5. Hence we get this linked list. As you can see here, the first linked list 1, here you can see we can get that 1, 3, 5, and after that the linked list 2 has been created, where we have used the append function again to create another 2 and 4, this linked list, right? Now next part, what they have done is that they have created another intersection point, and they have said that create the intersection point append. Okay, so what they have done is that they have created another linked list which they have merged both list 1 and list 2 into, and they have connected it. So this way they are able to intersect. Now list 1 has been called to intersect on the point 0 for the intersection point linked list, which is again this one, the 6 and 7 one. Okay, 6 and 7 are the new intersection linked list, and what they have done is that 2 and 4 is tail. 2 and 4's tail is getting connected to the head of the intersection point node linked list, and 1, 3 and 5's tail again is gonna get connected to the head of the intersection point linked list. So this is happening here, right? So now we'll see. So what they have done is they have created intersection, and they have called this function intersection, where they have passed the linked list 1's head and linked list 2's head. And what they have done is if the intersection is found, then they will print the intersection point and then the data of that intersection point like this, which will actually print the intersection point if there is any, if this condition becomes true. Otherwise, what it will print is no intersection found. This code is very simple to understand, and if you want to read out this append and get tail or intersect, you can pause the video and you can read that. Later, if you want me to explain the code for append, get tail and intersect, tell us in the comment section below and I'll do that. But as of for now, let's get to be on the point, and let's first write the find intersection point. So find intersection, what we are going to do. So here what we can do is we can use two pointers which is going to be assigned to list 1 and list 2. First pointer is going to get assigned to the list 1 and the second pointer will get assigned to the list 2. Then we will calculate that if the pointer 1 is not equals to pointer 2. So basically what happens is that we'll create a while loop, and where the first pointer next is going to get to the tail. If the tail is found, then that means, or what we can do is I can write something like this. First let's see what I can do is I can just say node star, let's say ptr1, and I'm going to assign it to list 1. Okay, so if you are wondering what is list 1, here this list 1 is the object of the linked list class up there. Okay, so that's the reason why I'm going to use this. So I've stored the object, the whole object into the pointer 1, and then I'm going to create another pointer node ptr2 equals to, and I'm going to say here as list 2. So this way I stored both the objects of the list 1 and the list 2 into pointer 1 and pointer 2. And once I do that, what I can do is I can say pointer 1, you go into you travel and go across and do keep on doing pointer 1 of next till you go into the list 2. Okay, if that is the case. So what I can write is I can write a ternary operation here. I can say here ptr1 question mark. If the ptr1 is going to ptr1 of next, and if it goes into list 2, and PTR2 goes into PTR2 ternary operation, PTR2 of next. If this goes into list 1, then the intersection point will be found. Now, how many times? This is a repetitive task. Again and again it will check, and what it will do is it will travel to the travel in its own node, and then it will try to go into list 2. If the list 2 ends, if the list 2 is touched, that means that's the point here. Same thing I'll do with pointer 2 and both. So basically what we are doing here is we are traveling from both list 1 head and list 2 head going towards this, and we are able to see, we are able trying to get into the list 2 and list 2 getting into list 1. If that is possible, then the intersection point is found, and wherever the intersection point is found, that data is printed as soon as they intersect each other. But traveling part in this case is a repetitive task. This part is a repetitive task. That means I need to write the whole code inside a while loop. That means I need to write the whole thing inside the while loop. So I'll say while, and while the condition will be, it will be like this. Just a minute. Okay, this is going to be like this. So while the condition will be till the PTR1 is not equals to PTR2. Okay. So this is going to be the condition. If this condition is true, till then, this condition, and do the same thing. And at last, what you will do is something has to be returned, right? Because you see that they have given the node star find intersection. So the whole node is going to get, returned back. So to do that, I'm going to say return. What I'm going to do, I'm going to return the PTR1 in this case, or you can return that as well, but I'm going to return PTR1 here. So what this is going to do is it is going to return the pointer, the node which is actually intersecting at that linked list intersection point, and this way we will be able to find that intersection point. So this is the code. So this is going to be the code for it. So basically we created two pointers, and then we are just checking in the pointers if they are able to go into the each other's linked list, and then we are returning that PTR1. So this is going to be the code. So that's it. Now we'll run the code. I'm going to save this code and then I'm going to run it. Let's see what's going to be the output. And the output is the intersection point of the data is 6. That is the right answer. So this is how you will find the intersection point, and I hope so that you have understood this video very well. If you have liked the video, tell us in the comment section below, and if you have any doubts, please tell us in the comment section below as well, and I'll try to clear your doubts as soon as possible. Well, don't forget to like, share, and subscribe to our channel Code Zakir, and don't forget to press the bell icon so that you won't miss any future updates. And yeah, that's all for this video. And if you need any help regarding linked list concept, I'll already be posting the links of all the videos related to linked list in the description below as well as in the I button, so you can go ahead and watch that as well. So that's all for this video, guys. Thank you for watching. This is Ashang David signing off, and I'll see you guys in the next one.